Today's probability question is called log comparison. And for this question, what we have is let x, y be identically and independently distributed functions that follow the uniform distribution from 0 to 1. Compute the probability that log of 2 of x, the floor of that is equal to the floor of log of 2 of y. So for this, basically what I did for this was just kind of thought about it. If I have a log function, it would look something like this, right? It would look something like this. And then basically what I would have is a function that looks like, wait, like this. That looks something like this with this curly thing. And then the region that I'm more interested in is between 0 and 1. So as x approaches 0 from the right-hand side, this is the right-hand side, log of 2 of x is tends to negative infinity. And as x goes to 1 from the left-hand side, basically we know that x equals 1 equals 0. So hence we're in the range of negative infinity to 0. So that would be kind of the domain the range we're working with. And then if we kind of just take the floor of that, it could just be any number from there, right? So let's just imagine, okay, if it was the case that um, log of 2 of x, floor of that would equal to negative 1. That's the first case, right? It can't be 0 because we can't get to 1 because it says from 0 to 1 not inclusive. So there's no chance we're going to get to 1. So hence the next one is negative 1, which would be our first one. And now we're just going to calculate the probability as log of 2x equals negative 1. What is this probability, right? We know that in order to make log of 2x equal to negative 1, that means that we're basically doing 1/2, right? If we're 1/2, this would be the chance of this. And then since it's identically and independently distributed, log of 2 of y would be the same story with also 1/2. And since both x and y are independent from each other, so then we can break down the log of this equals that as just a probability of each having it and then the sum of it. This is just the law of total probability. And then what we do is um, for 1/2, it would just be 1/2 squared. And then the next one, if it was negative 2, then we know that 2 to the negative 2 would give us 1/4. So then it would just be 1/4 times 1/4, 1/8 times 1/8, and then so on and so forth, plus it all together. So it would look something of this form. This is really hard to evaluate, right? We don't know what the square of something over something. So we can just change this form up into 1 over 4, 1 over 4 squared, 1 over 4 cubed, so on and so forth. We know the sum of this is just the infinite geometric series sum. So it's just 1 over 4 divided by 1 minus 1 over 4. So we get 1/3 as our final answer. So I think the major idea behind how to solve this question is just using the law of total probability and breaking it down into cases. So when it's -1, when it's -2, when it's -3, what are the probabilities? And then independently, using the independent case and then making that squared and then adding up all the squares together using the infinite geometric series. So yeah, that brings us to the end of this question.